Hello everyone, I'm Ved Patel, and today my topic is ternary logic systems. We will explore the efficiency and future of ternary logic in computing. So, what is ternary logic? What is digital electronics? Digital electronics utilize binary states 0 and 1 for operation. These systems are foundational to computers and communication technology. As we all know, logic gates are essential components in this electronic system. Circuits are designed to perform various operations based on logical inputs. Digital electronics have advancements in modern technology. Why do we use binary logic? Binary logic comprising two states 0 and 1. This cornerstone of computing technology. This binary system's simplicity enables effective use of transistors in computation. Transistors, fundamental components of computers, can be easily toggled between on and off states. Now, what is the limitations of the binary system? Digital circuits face limitations as they scale, mainly in complexity and power consumption. Increased complexity makes traditional binary system less effective. Higher power consumption is a growing concern. These challenges stimulate the exploration of alternative logical systems. And by exploring this, we found ternary logic. Ternary logic emerges as a potential solution for improved efficiency. Now we will understand what is ternary logic system. What is ternary logic? While binary logic operates with two operators 0 and 1, whereas ternary logic operates with three operators 0, 1 or 2, or it also can be minus 1, 0 plus 1. Now binary binary have only two operators 0 and 1, and ternary has three. It can be positive also or negative also. This computing system improves efficiency compared to traditional binary logic. With three states, ternary logic can process more information at once. The use of ternary logic enables more complex calculations and operations. Overall, it enhances the performance and capability of the computing systems. Now we will compare what is binary and what is ternary. Binary logic operates using two voltages, 0 volt and 5 volt, while ternary logic employs three voltage levels, 0 volt, 1.5 volt, and 3 volt. The use of three voltage levels results in lower circuit complexity. Ternary system offers more efficient data storage than binary systems. Now, how we can represent ternary number? Ternary numbers includes two classifications, unsigned 0, 1, 2 and balanced ternary minus 1, 0 or plus 1. Balanced ternary allows for efficient representation of both positive and negative values. This system offers significant computational advantages. It simplifies certain types of calculations, reducing overall complexity. The use of balanced ternary can enhance performance in specific computational tasks. Voltage levels in ternary logic. Ternary logic involves three voltage levels, 0 volt, 1.5 volt, and 3 volt. This level creates three distinct states for processing. This framework offers enhanced signal processing capabilities. Ternary systems foster greater computational accuracy than binary ones, because in binary there is two operators and in ternary there is three. Utilizing ternary logic can lead to more nuanced and effective computation. Why is ternary logic important for future computing? Ternary logic offers opportunities for enhanced circuiting and design efficiency. Its implementation can lead to reduced power consumption in computer systems. With growing computational demands, ternary logic is increasingly relevantly. Ternary systems can deliver superior performance while minimizing energy usage. These advancements may facilitate the development of innovative technologies, and it is less power consuming, so it is important in future for computing. Ternary logic gates, ternary NOT gate. As we know, binary NOT gates do 0 to 1 and 1 to 0. In ternary, 0 produces 2, while while 1 remains unchanged and 2 becomes 0. This operation enables effective state manipulation in ternary circuits. Such inversion facilitates complex logic operations in ternary systems. Understanding ternary logic is essential for advancing circuit design and computational efficiency. Ternary AND gate. The ternary AND gate determines its output based on the lowest value among its inputs. In binary, when one output is 0 and one is 1, then the output is 0. And if all the outputs are 1, then only if all the inputs are 1, then only output is 1. In this case, if the lowest value is considered, if any input is 0, output will be 0. If any input will be 1, and if the input is 1 and 2, then lowest value among 1 and 2 is 1. So its output is 1. And if there is 0 and 2, then lowest is low is 0. So 0. The, then all inputs are 1, the output becomes 1. With both inputs are 2, output is 2. So showcasing the gate's flexibility. This functionality allows for efficient decision making with multi-valued logic. Ternary OR gate. As, as in binary, OR gates do if both is 0, then only 0. If any of the input is 1, the output will be 1. In this case, the highest value from its input is considered the output. It effectively aggregates input values in ternary applications. When any input is 1 or 2, the gate delivers this value directly. For example, if the value is 0 and 1, the output will be 1. If 1 and 2, then 2. And if both the same, then same value. This functionality allows for complex data processing. The gate is essential for applications requiring ternary logic. Now, ternary XOR gate. As we know, in, in binary XOR gate, if any of the input is 1, then the output is 1. But in this scenario, the ternary gate is A plus A or B modulo 3. Means if just look like here input is 0, both input are 0, then this sum will occur 0 and divide by 3. So what is remainder? 0. So 0. Now in this case 2 plus 2 is 4, and if we divide 4 by 3, remainder will be 1. So output will be 1. So in this truth table of ternary XOR gate is of A or B modulo 3. Just add A or B and divide by 3. Whatever the remainder is our output. It output 0 if both inputs are 0 and if both are 0 are non-zero. Such functionality enables intricate decision-making processes. Ternary logic systems benefit from this unique decision-making capability. Ternary multiplexer. It is also called MUX. Ternary multiplexer allows selection of input values using a 2-bit selection input. It efficiently manages multiple signals in circuit designs, provides greater control in circuit functionality compared to binary multiplexers, enhances design flexibility by offering more input options, significantly improves data routing and management in complex circuits. Ternary decoder. Ternary decoder converts three distinct input states into a unique output. Each input combination triggers a specific line of output. This processes streamline complex logic functions. By reducing the number of circuit components, efficiency is enhanced. The ternary decoder simplifies the design of digital systems. How we can implement ternary circuits. Ternary CMOS technology. Now, CMOS is complementary metal oxide semiconductor. It operates at three distinct voltage levels instead of traditional two, which is in binary. The three voltage is 0 volt, 1.5 volt, and 3 volt. This tri-level operation enhances power efficiency in electronic circuits. The reduced number of required components simplifies circuit design. Overall, Ternary CMOS offers advantages over conventional binary systems. Memristor-based ternary circuits. Now, what is memristor? Memristor is nonlinear two-terminal electric component which offers a variable alternative for implementing ternary logic. They enable non-volatile storage, maintaining data without power. Their versatile functionality allows for compact circuit designs. These features contribute to improved circuit efficiency, increased efficiency, enhances overall memory capabilities. Resistor transistor logic RTL in ternary systems. Resistor transistor logic can be adapted for ternary systems. This adaptance uses a combination of resistors and transistors. Efficient ternary gates are created through this combination. Simpler circuit designs are achieved while maintaining functionality. Performance levels are also preserved in adapted circuits. Now, simulation of ternary circuits. There are many simulation tools such as SPICE, LT-SPICE, and Logism are vital for circuit modeling. These tools facilitate the modeling of ternary circuits, which operate on three states rather than two. They enable engineers to predict circuit performances accurately before physical implementation. This simulation enhances troubleshooting capabilities by identifying potential issues early. Now, for example, we made a circuit due to high voltage it breaks, but and the component is wasted. So if we don't let this happen, first try in any of these simulation tools, and if the circuit is properly working, then only we create the physical one, and it will work properly, and none of our component is is get waste. Using these tools leads to more efficient designs and reduced cost in circuit development as the components is not wasted. Now let's see some examples of ternary processors. Ternary processors are gaining attention in computing research. They offer significant advantages in processing speed compared to binary protection processors. Energy efficiency is notably higher in ternary. These benefits highlight the potential of advancement in technology. Ternary processors may pave the way for future innovations in computing. It is also be used for security purposes. Now, in binary, any of the hackers have to just predict 0 or 1. But in the case of this, input is more. So for the hacker, it is difficult to select between 0, 1, and 2. So it is also be useful in this one. And it is also used in encryption value and description value. So there are many uses of this, and it is very beneficial for future. So let's hope this technology will keep further growing and help everyone. Thank you.